Hi, I'm Kamakshaya, open source software evangelist and also a full stack web developer. In this video, I'm going to show you how to perform the chi-square analysis, also known as chi-square test. Chi-square test is performed especially when we have the bivariate data in hand, and most importantly, if the data is categorical, non-numerical, and small sampled data. So usually we don't perform the chi-square analysis for the large samples. The sample size must be small. I'm using Libre Office Calc for this demo, and you can use MS Office Excel. Doesn't matter. Only thing is the spreadsheet application must have the capability to produce a crosstab. We usually do that with the help of the pivot tables. So both Calc and MS Excel have the capability to create the crosstabs or continuous tables, and we use pivot technique. Okay, so now coming to the theory, if you are interested to read what is chi-square test, then there is a beautiful Wikipedia page here, chi-square test, something like that. There is also a kind of example here. Okay, the methodology goes like this. Chi-square statistic is actually a time by subtracting the expected frequencies from the observed frequencies and squaring them and dividing that squared difference by expected frequency. O minus E squared divided by E, something like that. We do call like that. So here the observed frequency is 90, and how to calculate the expected frequency. For 90, the expected frequency is going to be the product of this row-wise and column-wise totals divided by the grand total. See here, for 90, the column total is 150 multiplied by the row total 349 divided by 650. That is going to be the expected frequency. Now that value is 80.54. Now the actual observed frequency O minus the expected frequency E, 80.54 whole square divided by 80. And that gives rise to chi-square value. Now the sum of all these chi-square, the chi-square values for all these observed frequencies is going to be the chi-square value for the grand value for the test statistic. We call it as test statistic. That is going to be the chi-square statistic. And now there are two ways to, let me perform that first. Let me go step by step. Now I have this bivariate data in my spreadsheet, and I have 30 records, which means 30, the responses of the 30 different individuals. Now the variables are like this: gender and satisfaction. So it doesn't matter, satisfaction of something. That is not the interest of the study. It's just a plain. Now I'm interested to study the intergender differences to satisfaction. There are two ways to manufacture the hypothesis. Suppose if I am going for the differences, I can say that the intergender differences to satisfaction are insignificant. That is null hypothesis. And if I'm trying to interpret the data by dependency independency, that is also possible in chi-square test. The null hypothesis is going to be the variables in the study are independent, which means satisfaction does not depend on gender, something like that. So anyway, it is possible. Now the first step is just going to be like this. Okay. Now I need to prepare a contingency table, or otherwise I can also call it a crosstab. For that, in Calc we have a pivot table. So the same thing is also available from the MS Excel. So when you press this, then it is just going to identify the data from the automatically in the spreadsheet. Then when you press OK, it just brings up a context window, and in which you have these two variables. Now I can just drag one of the variables to the rows, the other variables to the columns. Now as a matter of kind of casualty, I can just get one of the rows here. Right now, don't worry, doesn't matter gender or satisfaction, just we need to fill the data field. Now what happens, it is not the sum. Actually I want to get the frequencies. When I double click in Calc, there is a kind of function called count, calculate by count. Now when I press OK, it creates a beautiful crosstab. So this is actually crosstab. However, there are formulas in this table. I'm just going to copy this. Even in MS Excel you have to do the same thing. Right click, paste special, unformatted text. Now what happens, you'll get plain text in the table, a table with a plain text. Now if you look at the values, you see most of the female respondents are highly satisfied and most of the male respondents are just satisfied. But is this difference, is it statistically significant? That is what is the focus of the technique, analysis. Now we are just going to calculate a chi-square statistic and find out if those differences are really a worthy observation, an input for the population. Is this are these differences are true differences, or just a matter of sampling error or simple random error or something like that? Now for that, what we need to do is we need to go for, as I have explained you, these are actually the observed frequencies. Now for each frequency we need to calculate an expected frequency. For that we can do manually like this: 3 divided by, it's not 3, the column total multiplied by the row total and divided by the grand total. Okay, that is one way. So I also, I follow the BODMAS always. You can just, anyway it is just not going to, so you can manually calculate all this. It is a small table, so it is easy for me to do this. But if you have a big table, then it is better to make use of the inbuilt functions. In both MS Office Excel and Calc, you got a function called mmult, matrix multiplication, something like that. Now what happens, as a matter of caution, first argument should be the row wise totals and second argument should be the column wise totals. Okay, now just leave the formula as it is like this, highlighted. Now Control Shift Enter, you'll get rest of the values calculated automatically with that stroke of buttons. Control Shift Enter, which is called array formula. Okay, that even do, you can also do this activity in MS Excel. Now we just only created the products. We have to go and we have to divide these values, these products, with the grand total, right? So what I need to do is highlight this, okay, or can just go here and then yeah, you can just take one of the values and then divide by the grand total and press enter. Okay, now what happens, just highlight this. Oh, I think here actually I have been doing a big okay, yes, what you need to do is you have to select the entire matrix and then divide it by the grand, then Control Shift Enter. You see you got the 3.4, the earlier value. Okay, now we got the observed frequencies and then expected frequencies. Now the rest of the activity is the sum of the, we need to calculate the chi-square values. How are we going to do that? So we can do one thing, O minus E whole square. Okay, O minus E, this is O, 3 minus 3.4 whole square divided by 3.4, and that is going to be the chi-square value. And then 9 minus 6.8 whole square divided by 6.8, that will be the chi-square value for this. And once we finish that, we can straight away go for the sum of the chi-square values, and then that is one way. But I'm not going to compute the chi-square value for each of the values. I have a small a shortcut way. What I need to do is I'll calculate the chi-square value from a function called chi-test. So this actually what it does is we can just simply hand over the observed frequencies instead of observed frequencies comma 2 different matrices and then expected frequencies. Okay, and now press enter. Now what you are going to get is actually the p-value. Now as per the statistical conventions, if this value is less than 0.05 at 5% significance level, we have to reject the null hypothesis, but we are not going to do that. Why? Because the value is 0.24. which is greater than 0.05. So at 5% significance level, we fail to reject the null hypothesis, which means both of these, the attributes, the satisfaction and the female, are independent from each other. In other words, I can say that the intergender differences to satisfaction are insignificant. So it doesn't matter. Those differences, the difference whichever we perceive here through these values from the expected values, is actually not that. If you compare value by value, here it is 3, 3.4, 9, 6.8, 5, 6.8. They're not big. The difference is not that big. Okay, so whatever the difference that we are finding here is not statistically significant. In other words, we may not be able to take decisions on satisfaction with the help of the intergender differences. So these intergender differences to satisfaction is not actually, it's not at all relevant for the decision. So that's how we can write the inference or infer from this analysis or the overall finding of the analysis. Thanks for watching this video. Stay tuned for the new content, and please subscribe to my video channel. Don't forget to like my video. Thanks once again.